The sun is necessary for the life of plants and humans on Earth. However, this massive energy source has the potential to destroy all forms of technology on the planet, including the world's greatest communication system. Solar flares, which are quite massive explosions of radiation from the sun's surface released rushing into space at tremendous speeds, present a threat from the sun, as per high-tech. Except rare radio blackouts, humanity is mostly unaffected by the sun's rays due to the geomagnetic field and atmosphere that act as a protective barrier from them regularly. A powerful solar flare might cause a large geomagnetic storm, which can damage the online services, mobiles, satellites, electrical grids, and other electronic devices. Not only may power, internet, and GPS systems be disrupted, but they can also impair daily communication. Everything is affected, including phone calls and internet access, and it could be down for months because repairing the destroyed and damaged infrastructure will require a lot of time. These solar storms, on the other hand, do produce something beautiful, auroras. The northern lights, often known as auroras, can create a stunning display in the sky. Auroras are formed when charged particles from the sun are trapped in Earth's magnetic field and transferred to the Earth's upper atmosphere, which is the ionosphere. NASA explains how those intriguing lights in the sky are generated on the poles. The disturbance of Earth's upper atmosphere caused by coronal mass ejection from the sun's outer atmosphere, or corona, is referred to as a geomagnetic storm, as per Britannica. Charged particles with energies of a few thousand electron volts make up the majority of the material involved with these eruptions. This material, known as plasma, travels across the interplanetary medium at rates ranging from less than 10 km per second to far more than 2,000 km per second, taking around 21 hours to reach Earth. The entering plasma's pressure is communicated to the Earth's magnetosphere's outer edge, causing a rise in the observable Earth's magnetic field at the ground, possibly via hydromagnetic waves. The horizontal component of the Earth's magnetic field grows quickly over the entire globe during the storm's sudden commencement phase, which lasts only a few minutes. The spike lasts 2 to 6 hours and therefore is defined as the storm's early phase. The freshly generated magnetic lines in the core of the tail compress fast in reaction to this unstable condition, propelling plasma from the neutral sheet of the geomagnetic toward the night side of Earth. The contractions in the polar regions cause intense auroral displays, while the contractions on Earth cause a severe magnetic disturbance known as a polar substorm. This is continued by the storm's main phase, which lasts 12 to 48 hours and is characterized by the horizontal component. The 1859 geomagnetic storm, commonly known as the Carrington Storm, was the largest solar storm ever recorded. The storm, which hit on September 2, 1859, resulted in spectacular auroral displays far as south as that of the tropics. The increased electric current running via telegraph lines ignited recording tapes at telegraph stations, causing fires. The first discoveries, a bright spot of a white light solar flare instantly appearing on the sun, were made the day before by Richard Carrington, a British astronomer of the Royal Greenwich Observatory. He recognized the coincidence between the geomagnetic storm and the discovered solar flare, thus predicting the field of space weather study. The active area of the sun that created the white light flare is now understood that it creates a fast coronal mass ejection, a huge outburst of magnetized plasma that caused the geomagnetic storm. Although CMEs are commonly associated with solar flares, they can happen both individually. I hope you love this video. If yes, follow us on Facebook and subscribe to our channel on YouTube. Thank you.